Here we have a page of notes that addresses how the capacitor process of charging changes or doesn't change when we add a resistor in parallel to the capacitor that's charging. So in this case, we have the capacitor charging through R2, and we've added a resistor R1 in parallel. Well, as far as the charging capacitor is concerned, it sees the voltage of the battery just like it did without the parallel resistor in there. So the charging process for the capacitor will not change based on the R1 that's added. So the charge across the capacitor still equals its fully charged value, 1 minus e to the minus t on R2C only. So it's really blind to what's going on with R1. R1 sees the full battery voltage immediately. So what's presented here is a really endpoint analysis. By endpoints, I mean what's going on right at the beginning of the charging process and what's going to happen after the charging process is complete relative to what the battery is doing. Okay, so keep that in mind. So right at time t equals 0, there's no charge on the capacitor, so there's no back voltage being generated. So as it says here, please get this into your notes, that the capacitor acts like a closed switch. In other words, we can ignore the capacitor. So at time t equals 0, we can just take a straight wire and replace the capacitor with a closed switch or just a straight wire, and our analysis is now based on two resistors in parallel. So the battery, right at time t equals 0, would behave just as it would behave with resistor R1 and resistor R2 in parallel. We can calculate the equivalent resistance. This is now simple for us, the equivalent resistance. We can calculate the current going from the battery. We can calculate the current going through R1 and R2. All right. Well, what about time t equals infinity when the capacitor is fully charged? If the capacitor is now fully charged, it has shut off the current going in that branch of the circuit. So at time t equals infinity, we have no current flowing through this branch of the circuit at all. So the only thing the battery now sees is the resistor R1, and the battery behaves, in terms of behavior, I mean pushes out current according to just what it's pushing through resistor 1, this 2 ohms, so we have just the 5 amps. So I added this page of notes because it's often asked as a concepts question in multiple choice, and I found it helpful for students. Now, as the last point of discussion, you may note that we don't have a page of notes for resistors in series. If a resistor is in series, so let's just do that. We can do it down here. If I add a resistor in series, so let's say I add a resistor here to the charging process. Well, we still have one loop, and our charging process really hasn't changed at all from what we did initially. If they're in series, the RC, for the charging process becomes R1 plus R2C. Because they're in series, the resistors add. It really doesn't change our analysis at all. So there you have it. Please make sure you get your notations down here, and as always, if we need to discuss it together, we absolutely will.